we're going to be looking at changing a function that is given to us in vertex form into standard form and what advantages that might give us. Then we're also going to look at some word problems comparing a standard form quadratic function with maybe a quadratic function given to us by a table of values. And again, this is going to be focused on the last 6 problems on your homework. These problems won't take as long as the first 4 problems did, but you do have to know how to manipulate an equation a little bit, so we'll see how we feel about this. It depends. We'll see how long these notes take us.
I hope it takes super long.
No, I still have to do it for homework.
Well,
Could you sign for Valentine's Day?
What's that?
You don't know what Valentine's Day is? It's tomorrow.
Is it really?
yeah.
Or y'all are dumb. He absolutely does know what it is.
You're the one who asked.
He's super excited, isn't he? Somebody's
What's up
holding
with
his
this
breath.
A-train trend that I keep seeing on TikTok?
What?
The A-train trend?
Oh my god.
Yeah, I saw. Oh my god, look at that.
I am
Okay, so here I'm given a quadratic function. Look at its form. It is in vertex form. F of x equals a parentheses x minus h close parentheses square it plus k. Now it tells me the directions. Take this that's in vertex form and write it in standard form. So the good news is, once you learn the process, it's the same every time. The only thing that's different is the numbers. So here's how we move from vertex form to standard form. First thing, we must simplify this, so we're going to be thinking about our order of operations. So do I have anything in parentheses that can be simplified? So what's in parentheses is x plus 1. That is not like terms, so I have nothing to simplify inside parentheses.
Are we going to distribute?
We are. Ain't that crazy? Something we've been working on. Now we're going to use it here. Next, do I have any exponents?
Yes.
I do. I have x plus 1, and that's being raised to the second power. What does it mean to raise something to the second power? Multiply it by itself. So I'm going to take what's in parentheses, x plus 1, and I'm going to multiply it by itself, x plus 1, because the x plus 1 is being squared. Now, what mistake do you guys think is made all the time on this kind of problem?
2x. People put 2x instead of x squared.
Maybe. The thing I see the most, people will take x and square it, x squared. They will take 1 and square it, 1. And they think they're done. It's x squared plus 1. If you do that, you will miss it. If the whole thing is being squared, you can't square the first term, square the second term. That is not how it works. You must multiply the parentheses by itself. Okay, I'm going to bring down the minus 3 as well. Now I have no more exponents. Do I have anything that's telling me to multiply or divide?
2 parentheses and the 4.
All of these are being multiplied. I'm multiplying 4 times x plus 1 times x plus 1. That's 3 things being multiplied. You can multiply in any order. So like you could multiply the 4 times the x and the 1. You can multiply the 4 times this x and 1. For me, if there's ever a monomial, one term out front, it's always the very last thing I do. I think it makes it easier. So for me, I would multiply the x plus 1 times the x plus 1 first. Multiply your parentheses by each other first. So what must I do to multiply those parentheses, I need to distribute. Okay, so I'm going to multiply the x plus 1 times the x plus 1. X times x is x
X squared.
squared.
Oh my god, I just said that mistake.
X times x is x squared. X times 1 is 1x, or just x. Now, 1 times x is 1x, or just x. 1 times 1 is 1.
You need to
We and then do I have any like terms I can combine? I can combine the x plus x. What is x plus x? That is not x squared.
2x.
It is 2x.
X squared is when you multiply.
When I'm adding like terms, I keep the variable the same, combine the coefficients. 1 plus 1. You guys have got to get those rules straight. I've drilled it and drilled it. I don't know what else to tell you. At some point, you just got to memorize it. I mean, there's not much more to it. When I'm multiplying, I add exponents. When I'm multiplying, I add exponents. When I'm adding, I don't do anything to the exponents. They stay the same. So these combine to be 2x. Bring down the x squared, bring down the 1. So is there anything left here that will simplify? No, none of those are like terms.
Yet, it's also in the standard form too.
Now I'm going to bring down the 4 that was out front, and I'm going to bring down the minus 3 that was at the end. You see how I'm bringing those down with me? If you wanted to leave them here, you could have. I typically just wait until I've got it completely simplified and bring them down. Okay, so I'm still on multiplying. Do I have anything else to multiply?
4 times x squared.
4 times everything that's in parentheses. So what is 4 times x squared? 4x squared. 4 times 2x. 8x. 4 times 1. 4. Now I've completely done multiplying, so I can drop those parentheses. But I need to make sure what? I remember to bring down
Minus 3.
the minus 3. I have nothing being multiplied or divided anymore. Is there anything being added or subtracted that I can simplify?
4 and the 3.
4 minus 3, those are like terms. 4 minus 3 is 1. Do I have any more like terms?
Can you do 4 and 8?
No.
It has to be the same exponent.
I must have the same variable raised to the same power to combine like terms. So no, I cannot.
That's standard form. Put that in calculator.
So now I've taken a parabola in vertex form, and I've converted it to be in standard form. What I want you to do very quickly is I want you to go to your graphing calculator.
Is that like the A over B method thing?
Yes, that's standard form. AX squared plus BX plus C. That is the standard form. Look, y'all got to calm down back there. I don't know what y'all are doing. Y'all kicking desks, making a bunch of racket. Yeah. That, I didn't bring that up.
We all know, Blake.
So, in your y equals form, I want you to put this in first. 4, parentheses, x plus 1, close parentheses, squared, minus 3.
And then put what we got at the end.
And then on the second graph, I want you to put this one in. 4x squared
It's the same.
plus 8x plus 1.
Tell me, I want to do this. And graph it.
And graph them.
Ziggity zang.
The second one is this one down here. 4x squared plus 8x plus 1.
But I don't see a 2. That's confusing. That just confused me. What? The graphing part.
Why did it confuse
I
you?
don't know if it did. It's just.
These are the same parabola. They're the same equation in two different forms. And I converted it from vertex form to standard form. But they still point to the same thing. They both are parabolas that open up, have been stretched by 4. This one, we could think of it as moving the vertex left 1 and down 3. If I put in negative b, negative 8 over 2 times 4, that's going to be negative 8 over 8, which is negative 1. So the axis of symmetry is at x equals negative 1, which means it got shifted left 1. Right? You see how it's the same thing. They're pointing to the same properties. What's different, this one can tell me the y-intercept is 1, where this one doesn't tell me that. Right? That's one of the advantages of standard form.
When you're doing standard form or whatever, like when you're changing it down, would you just forget about that f equals x? F of x?
Yeah, you can, the f of x is just like saying y equals.
Yeah.
So, I mean, at the very end, I probably should have put it back as f of x equals.
Yeah.
But it does not, you do not do algebra with the f of x.
Yeah.
Ever. It just stays by itself.
I got you. So what was the vertex form, like the letters? Was it like f of x equals
A, parentheses, x minus h, close parentheses, squared
minus k
plus k.
plus k?
Plus k.
Okay. I just didn't have it as a side note.
The only one that's minus is the one in parentheses because it does the opposite of what it looks like it should do. So a lot of people I'm seeing are getting answers and a lot of people are missing it. So let's go over this one. Again, y'all's algebra, simplifying equation skills are not where they need to be. Right? I've been saying that from the get-go. Being able to manipulate an equation is a skill you've worked on since you were in 7th grade. Now this one's a little bit uglier, a little bit harder, but your skills are not great. So I'm going to show you what I would do, and you look on your paper, see where you messed up. Okay, here's first. First thing I would do, just everybody look. I can't answer everybody right now while I'm going over it. I see x minus 9 is being squared. That means I want to multiply it by itself. So I should have x minus 9 times x minus 9 plus 15. Does anybody have a question on that step? Has anybody messed up there? Okay, next. I told you to distribute here. Right, what's in parentheses? So what is x times x?
2x.
No.
X squared.
X squared. X to the second.
Yeah, it does.
X times negative 9. Negative 9x. Negative 9 times x. Negative 9x. Negative 9 times negative 9.
81.
Positive 81. Bring down the negative 2. Bring down the positive 15. Anybody confused on those steps?
Oh.
Do I have any like terms? Negative 9x minus 9x combines to be negative 18x. Do I have any questions on that step?
I know what I did wrong. I distributed everything out, but the 18, I don't know why. I just kept the 18 the same. That's how I missed it.
Bruh, I should have.
Did you? Did you work down the paper? You getting more? You getting more organized?
Yeah, I worked down.
I'm proud of you.
I'm even stapling it.
Look at you. Thank you.
Staple this.
Thank you. And that's probably why you could see why you had a mistake, because you could look back at your work. Look at that. It's amazing.
This ain't Thanksgiving.
I got like.
Everybody's good here. I saw some people cancel these out.
Bro,
They made it zero.
don't do that to me, bro.
I saw some people say a negative and a negative was positive.
That's kind of dumb.
No, it's not. I'm just telling you. Out of everybody I looked at your parabolas, I didn't see anybody that got them right the first time. So I know you sit there and think, I don't need to say anything because I'm the one that doesn't know what's going on. No, I've looked at all of them. None of you know what's going on, right? Very few. So speak up. You're not the only one. There's a reason I keep going over this over and over because you're not good at it.
I put dang negative and negative 9.
Sometimes y'all gotta have a reality check. You gotta be real with yourself. Everybody lives in this fantasy world that, well, I'm just gonna stay in my bubble and I don't want anybody to know that I don't know what's going
If I'm
on.
wrong and this thing ain't lining up,
Well, I appreciate it.
I'm telling you.
Yeah, I know I'm done.
I'll make your job harder.
Any questions on this step? If you're not good at the algebra, put in your calculator, -9, -9. It will tell you. Right? It does it for you.
My struggle is like when I'm graphing or like putting it. Like I was
Yes, you clicked the wrong sign.
Negative or
Yes.
minus.
Well, and they'll spit out at you and say error. So, I mean, you'll... Okay, next thing I would do, distribute. What is -2 times x squared? -2x squared. -2 times -18x. Positive 36x. Again, if you're not sure, put it in your calculator. -2 times positive 81 is -162.
That's a 2. My bad.
If you're not sure, put it in your calculator. Plus 15. I'm just trying to get y'all like. Okay. Bring down the plus 15. Any questions here? Do I have any like terms? Yes, I have like terms again. So combine -162 and 15. That combines to be -147.
Yes, dummy.
Whoa. Language.
Okay, so looking here, I have negative x plus 3 being squared plus 8. If it's being squared, that means I'm multiplying it by itself. So the negative comes down front. The x plus 3 is being multiplied by itself. X plus 3 plus 8. Questions on that step? Multiply it by itself. Next, distribute. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9, not 6. Bring down the plus 8. Bring down the negative that was out front.
Wait, I wasn't the only one who did that?
I'm sure you're not.
Well, I mean, I know that 3 times 3 is 9.
Combine your like terms. 3x and 3x combine to be 6x. Bring down the negative. Bring down the plus 8.
Is there gonna be one where it's like 3? It'll be a triangle.
No, because vertex form has to look like this. So it's always going to work out like this. Every time. Now there's a -1 that's out front. Distribute it. -1 times x squared is -x squared. -1 times 6x is -6x. -1 times 9 is -9. Bring down the plus 8. Do I have any like terms? These are -9 plus 1 is -1. I have -x squared minus 6x minus 1. Standard form. So here, look at this. We got this beautiful fountain. It's just wonderful. Now, you notice there are all of these water features that are shooting water back into the fountain. Well, look at the shape of the water going back into the fountain. It's a parabola. Fountain A is given, the equation of the parabola is given here. Negative x squared plus 2x plus 8. That's the shape of this parabola. Okay, now this parabola, part of fountain B, it does not give me an equation, but it gives me a table of values. So when I look at the table of values, it looks like it goes and reaches a maximum of 10 before it starts back over, going down. So this would be your vertex, right? Your vertex is at negative 410. That's the highest point. So the question here, the trajectory of the water fountain from fountain A is represented by a function in standard form, while the trajectory of the water from fountain B is represented by a table of values. Compare the vertex of each function. Which trajectory reaches a greater height in feet? So just looking, it looks like fountain A is a little bit higher to me. But I don't know that. I know fountain B reaches its highest value at 10. That's the vertex. That's the y value. So how can I find the highest point of this parabola? I'm looking for the vertex of this parabola. How can I find the vertex when it's in standard form?
Is it put it in your graphing calculator?
Well, you could put that in your graphing calculator, and you could then go find the vertex. That's one option.
Or the table of values does that.
Or you could look at the table of values, or the way we find the vertex when it's in standard form. We can find the axis of symmetry by using the formula. X equals negative b over 2a. In this case, that would be negative 2 over 2 times negative 1, which means the vertex occurs when x is, that's positive 1. So what is the vertex? Well, the vertex is going to be at 1. How can I find that y value?
Well, it's in the equation.
I take 1 and I plug it in to x in my original equation to find the y value. So this would be f of 1 equals negative 1 squared plus 2 times 1 plus 8. You can put this directly in your calculator. I know 1 squared is 1, but there's a negative out front that makes it negative 1. 2 times 1 is 2 plus 8. I combine like terms. That's going to give me 9. So the height of fountain A, its highest value is 9. But the highest value from fountain B is 10. So which fountain has a greater height? It's fountain B.
But
By 1 foot.
Could you lift that up there for a little bit?
I will. Look at this one. Compare f of x equals negative 0.3 x squared minus 0.6x minus 0.2. That looks ugly. Look at all those decimals.
No, ain't that bad.
Now, they want me to compare it to this graph. Okay, so there are two different graphs. This is function f here. This is the graph of function g. What are the maximum values? And which function has a greater maximum value? So look at the graph. What is the maximum value for g? What's its highest value? Well, the vertex is at 3, 0, which means its highest y value is 0, occurring at 3. Everybody in? That's the highest y value. Now, how can I find the highest y value of this junk?
Plug it into your calculator.
You could put it in your graphing calculator.
Find the
I don't have one. I'm going to find its vertex by using the axis of symmetry. X equals negative b over 2a. So this is negative. B is negative 0.6. So that's a positive 0.6 over 2 times a, which is negative 0.3. So this looks awful,
Sounds awful.
but it's not. This is 0.6 over negative 0.6, which means the vertex occurs when x is negative 1. Worked out kind of nice. I can take negative 1 and plug it in to find the actual vertex. It occurs at negative 1 something. So if I plug in negative 1, this is negative 0.3 times negative 1 squared minus 0.6 times negative 1 minus 0.2. So this would be negative 0.3 times 1. That's a positive 0.6 minus 0.2. Negative 0.3 plus 0.6 minus 0.2. I combine all those like terms, I get 0.1. Again, you can put this directly in your calculator, right? It will simplify it for you. You don't have to know how to simplify it like I do. Just put that in your calculator.
Not now.
So what's the height of F? 0.1. What was the height of G?
0.
0. Which one's higher?
The first one. G.
F.
F. Yeah.
0.1 is higher
Oh.
than 0. 0.1 is higher.
Ziggity zang.
So you just look at the log?
That's how you tell height.
Oh,
This number tells you where it occurs. At negative 1, it reached a height of 0.1. At 3, it reached a height of 0. Which one's higher? 0.1 is higher. Remember, the x is the time. It's like a timeline. I'm reading from left to right. West to east. Let him go. What'd you say? I couldn't hear you.
Oh, I said, vote on that to do work problem. Easy, so yeah.
Why not?
No,
I read the code, and I all said it was a massive block.
Oh yeah.
I really gotta figure that out.